Hey guys, today we will discuss about uniform continuity of a function and its application. So let's start. Uniform continuity. Let's see what is its definition. A function fx is said to be uniformly continuous on an interval I subset of R. For each epsilon greater than 0, there exists a delta greater than 0 depending on epsilon only. This delta should be depends on epsilon only such that mod f of x1 minus mod f of x2 less than epsilon whenever mod of x1 minus x2 less than delta for all x1 x2 belongs to R. So here we have to notice that uniformly continuous on an interval I subset of R. Obviously, this uniform continuity works in an interval. So here we can say that between uniform continuity and continuity there is some difference. Like as uniform continuity works on an interval such as I or closed interval AB or any open interval AB such like, but continuity works on only at a point such as x equal to a. So to evaluate the continuity of a function, we just discussed the value of a function at a point, but we will discuss for uniform continuity the value of a function in whole interval. And that's why uniform continuity is a global property and continuity is a local property. And also here delta depends only on epsilon, but in continuity there was no any limitation. So this is the basic difference between uniform continuity and continuity. Okay. Now we will discuss about some example. So let's see. This is the question. We have to show that this function fx equal to sin x is uniformly continuous on R, where x belongs to R. So let's try by our definition. Here we have to evaluate the uniform continuity in R. So obviously we have to take another point in R. So let C belongs to R. Then for any x belongs to R, mod f of x minus f of c equal to sin x minus sin c. Now by trigonometric formula we get that x minus c by x plus c by 2. Here just modulus is distributed. Okay, now we know that mod of cos x less or equal to 1, so we can say sin x minus c by 2. Okay, now again sin x less or equal to x less or equal to mod of x minus c. Then we can write that thus for any epsilon greater than 0, satisfying mod of x minus c less than delta equal to epsilon, we find that mod f of x minus f of c less than epsilon, hence fx equal to sin x is uniformly continuous. Okay. Now we move to next example. This is the question. We have to show that fx equal to root x is uniformly continuous in this interval 0 infinity. Now similarly we will proceed. Let c belongs to 0 infinity for any x belongs to 0 infinity mod fx minus fc root x minus root c. Now we have to multiply here mod of root x plus c with numerator and denominator. So here we can say mod of x minus c root x plus root c. Okay. Now here this is a part of our concept. Here we can say that mod of x minus c x minus c root of, how? Obviously, now we can say that mod of root x plus root c equal to root x plus c if x greater than c and x c both are greater than 0. Again, if this happen, then it will be too much large mod x from this one, and when this is too much large, then we can subtract c from x. So by this way we get this. Okay, and then we can write root over of x minus c. So by the previous example we can say for any epsilon greater than 0 satisfying mod of x minus c less than delta. Here the value of delta is epsilon square. Here mod of fx minus fc less than epsilon, because by the definition we have to move us at that point. So here delta equal to epsilon square. We find that mod of fx minus fc less than epsilon. Hence root x is uniformly continuous. Where? In 0 to infinity. Okay. This is our problem. understand just this step, and then you can solve all over the problem. So today I end this lecture here. If this video is helpful for you, then please hit the like button and share this video with your friends. So goodbye.